For centuries, we've pretty much accepted that aging is inevitable. It's just a fact of life, right? But what if it isn't? What if aging is less of a fundamental law and more of a technical problem that we can actually solve? Today, we're diving deep into how science, biohacking, and AI are all coming together to take on one of our oldest enemies, mortality itself. So here's our roadmap. We're going to start small, I mean really small, right inside your cells, to understand a hidden energy crisis that's affecting all of us. Then, we'll talk about how to literally flip your body's longevity switch. We'll look at a wild case study of someone taking this to the absolute extreme. And then we'll zoom way out to see how AI is completely changing the game, pushing us toward a future you might not even recognize. All right, let's start at the microscopic level. You know that deep, bone-tired feeling that a good night's sleep just can't seem to touch? Well, you're not imagining it. And the real reason might not be your busy schedule, but a massive power failure that's happening inside your body's own power grid. Seriously, it's a question we all ask ourselves, right? And the answer goes so much deeper than just, I need more sleep or maybe less coffee. The real problem is that our body's power supply is starting to fail, and it's happening at the cellular level. This right here, this is the scene of the crime. Inside almost every single one of your cells, you have these little power plants called mitochondria. But as we get older, and because of things like chronic stress and inflammation, they start to break down. They get less efficient and they produce less energy. You're literally looking at cellular decay in action. So just imagine each mitochondrion is a tiny factory. It has one critical job. Take the fuel from your food and run it down a super complex assembly line to produce something called ATP. And ATP, well, that's the actual energy currency that powers everything you do. Every heartbeat, every muscle movement, every single thought, it's all paid for with ATP. Now, for that factory to run, it needs a budget. It needs funding. And that funding comes in the form of a molecule called NAD+. Here's the kicker, though. By the time you're 50, your NAD+ levels have dropped by about half of what they were when you were 20. Half! With less money in the bank, the whole factory assembly line just slows to a crawl. ATP production tanks, and you feel that drop as pure exhaustion. Okay, so if our cellular power grid is failing, the obvious question is, how do we fix it? How do we get the lights back on? This is exactly where the world of biohacking comes in. It's all about using targeted strategies to send signals that force our biology to upgrade itself from the inside out. It turns out our bodies are hardwired to respond incredibly well to short, manageable bursts of stress. Things like high-intensity exercise, or going without food for a bit, or even a shocking plunge into cold water. They're not just about mental toughness. They are direct, powerful signals to your cells. They basically scream, hey, we're under pressure here. We need more power, and we need it now. So how do these stressors work? Well, they activate a master regulator called PGC1 alpha. And you can just think of this as the longevity switch. When that switch gets flipped on, it sends a powerful message all over your body. Clear out the old, busted mitochondria and build new, shiny, more powerful ones. And we can actually help this rebuilding process from two different angles, which is really cool. On one side, you can tackle the fuel problem. Supplementing with things that boost NAD+ is like giving that factory a bigger budget to work with. But on the other hand, you can fix the faulty wiring with compounds like methylene blue. Think of it like a cellular electrician that helps the energy assembly line run smoothly, even bypassing some of the damage aging has caused. So we've covered the theory. But what happens when you take these biohacking principles and push them to the absolute logical extreme? What does it look like when one person dedicates their entire life and a whole lot of money to systematically reversing their own aging process using cold, hard data? Well, meet Brian Johnson. He's a tech entrepreneur who spends over $2 million a year on an incredibly disciplined, data-obsessed regimen he calls Project Blueprint. His entire life is basically one giant experiment to see if he can literally turn back his biological clock. And the results, according to his own data, are kind of staggering. He claims to be aging way, way slower than a normal person. And if you look at his markers like inflammation or cardiovascular fitness, his health metrics are as good as, or in some cases even better than, your average 18-year-old. It's a real-world, if totally extreme example of applying those cellular principles with absolute precision. Now, Project Blueprint is built on a mountain of data, and that is the perfect bridge to the next great leap in longevity. We are now starting to use artificial intelligence to decode the insane complexity of aging and design targeted solutions like we never could before. This is where the problem just gets too big for human scientists to handle on their own. AI isn't just a tool here, it's becoming the core engine of longevity research. Just imagine AI platforms like AlphaFold 3 designing brand new anti-aging drugs from scratch, or systems like Delphi that can sift through your health data and predict a disease 20 years before you even have a symptom. This is what's making the dream of engineering our own biology a potential reality. So this is the vision, right? This is the end game that all these technologies are building towards. We're moving away from a world where we just accept our biological limits, aging cells, shortening telomeres, and toward a future where we can actively engineer the solutions, using things like gene therapy and nanotechnology to repair our bodies at a cellular level. And as AI just keeps accelerating the pace of discovery, we arrive at the final frontiers of this whole quest. We're talking about two goals that, until pretty recently, sounded like pure science fiction: achieving biological immortality and, maybe as a backup plan, digital immortality. Okay, this concept is called longevity escape velocity. It's the tipping point where science and medicine are adding years to your life faster than time is passing. So for every year you live, you gain more than a year of life expectancy. Some people, like the futurist Ray Kurzweil, think we could hit this point as early as the 2030s. If you're alive and healthy when that happens, you could theoretically stay ahead of aging forever. But what if our biological bodies are just the weak link in the chain? There's a parallel field of research exploring mind uploading. The idea is to map your brain's entire neural network and then upload that consciousness to a digital form. It's the ultimate backup of you. And this, of course, raises one of the biggest, most mind-bending philosophical questions there is. Is your identity, your you-ness, tied to your physical brain? Or is it just the pattern of information that your brain holds? If a perfect digital copy of you lives on after your body is gone, did your consciousness really continue? But even if we overcome every single technical challenge, even if we figure all of this out, we are left with what some people call an everything puzzle. It's this cascade of enormous ethical and societal questions that, frankly, we have no answers for yet. On one hand, you've got this incredible promise, a world free from the suffering of diseases like Alzheimer's or cancer. But on the other hand, the peril is a future with a longevity gap, creating a new class of biological haves and have-nots. A world of ultra-long-lived elites on a planet that's already groaning under the weight of 8 billion people. And the path forward is just littered with these massive obstacles. We are literally up against the laws of physics, which say that everything in the universe tends toward disorder and decay. We're up against demographic data that suggests we might have already hit a natural ceiling on our maximum lifespan. And, of course, we face the huge ethical questions of who gets access to this technology, and can our planet even sustain us? And that really brings us to the final and maybe the most important question of all. It's entirely possible that cracking the biological code of aging will turn out to be the easy part. The far greater challenge will be a philosophical one: figuring out what it truly means to be human in a world without end, and what on earth we're supposed to do with all that extra time,